Warm welcome to all of you. Today we will discuss about features of supervised machine learning. The first one is supervised machine learning uses labeled data. Supervised machine learning works with labeled datasets where the correct output is already known. The model learns by comparing its predictions with the actual labels. For example, in email spam detection, each email is already labeled as spam or not a spam, which helps the model learn accurate classification. In student results analysis, past student records contain labels like pass or fail, which guide the learning process. Supervised machine learning works only with the labeled data. Labeled data means that for every input, the correct output is already known. During training, the model compares its predicted output with the actual label and learns from its mistakes. This comparison is the foundation of supervised machine learning. For example, in email spam detection, every email is already labeled as spam or not a spam. The model studies these labels and learns how to classify a new email correctly. Similarly, in student results analysis, past student records contain labels such as pass or fail. The model learns the relationship between marks and results. So labeled data acts as a teacher guiding the learning process. Next one, clear input to output mapping. There is a well-defined relationship between input features and output labels. This makes supervised learning structured and easy to train. For example, in the case of house price prediction, house size, location, and number of rooms are mapped directly to house price during training. Patient symptoms are mapped to disease type for accurate medical diagnosis. In supervised machine learning, there is a clear and well-defined relationship between inputs and outputs. Each input feature is directly mapped to a known output label. This makes supervised learning structured and easy to understand. For example, in the case of house price prediction, house size, location, and number of rooms are mapped to house price. In medical diagnosis, patient symptoms are mapped to disease type. Because this mapping is clear, the model learns faster and produces reliable predictions. So the next one is requires training phase. The model must be trained using historical labeled data before making predictions. During training, errors are minimized continuously. For example, a credit scoring model is trained using past customer loan repayment data. A face recognition system is trained using labeled face images of known persons. Supervised learning always requires a training phase. During training, the model uses historical labeled data and continuously minimizes errors by adjusting its parameters. For example, a credit scoring model is trained using past customer loan repayment records. The face recognition system is trained using labeled face images of known persons. Without proper training, the model cannot make accurate predictions. The next one is predictive in nature. Supervised machine learning is mainly used for prediction tasks on unseen data. It predicts outcomes based on learned patterns. For example, the model predicts whether a student will pass or fail based on academic history. Sales forecasting models predicts future sales using past sales records. So supervised machine learning, by nature, it is a predictive in nature. The next one is high accuracy. Supervised learning provides high accuracy when sufficient quality labeled data is available. Accuracy improves as training data increases. So supervised learning provides high accuracy when sufficient quality labeled data is available. So medical diagnosis systems accurately predict diseases using well-labeled patient data. Speech recognition systems achieve high accuracy due to large labeled voice datasets. When sufficient quality labeled data is available, supervised learning provides high accuracy. Accuracy improves as the amount and quality of training data increases. Medical diagnosis systems accurately predict diseases using well-labeled patient data. Speech recognition systems achieve high accuracy due to large labeled voice datasets. Hence, labeled data directly impacts on the accuracy of the model. So the next one is error feedback mechanism. The model receives continuous feedback by comparing predicted output with actual output. This feedback helps to improve the performance of the model. For example, in regression models, the difference between predicted and actual value is used to reduce the error. So here we are trying to compare predicted and actual values to minimize the errors existed in the model. In classification, wrong predictions are used to update model parameters. In supervised learning, the model receives continuous feedback. It compares predicted output with the actual output, calculates errors, and improves the performance. In regression models, the difference between predicted and actual value is used to reduce the error. In classification models, wrong predictions help to update model parameters. So the next one is suitable for classification problems. Supervised machine learning is ideal for classification where output classes are predefined. The model assigns inputs to one of the known categories. For example, emails are classified as spam or non-spam using trained classifiers. Bank transactions are classified as fraudulent or genuine transactions. So supervised learning is ideal for classification problems where output classes are predefined. The model assigns each input to one of the known categories. For example, emails are classified as spam or non-spam. Bank transactions classified as fraudulent or genuine. Classification problems are one of the most common applications of supervised machine learning. The next one is sustainable for regression problems. So supervised machine learning more suitable for regression problems. It is also suitable for regression problems where output values are continuous in nature. These models help in numerical predictions. Salary is predicted based on experience, education, and skills. Temperature is forecasted using historical weather data. So supervised learning is also suitable for regression problems where outputs are continuous values. Regression models help in a numerical prediction. For example, salary is predicted based on experience of an employee, educational qualifications of an employee, and skills of an employee. So temperature is forecasted using historical weather data of past 1 month or from past 3 months. The supervised learning handles both classification and regression tasks. So therefore, it is known that Supervised learning handles both classification and regression tasks. So next one is faster learning process. Learning is faster because the correct output is already known. The model quickly adjusts the parameters. Linear regression converges quickly due to known target values. Logistic regression learns faster than clustering algorithms. So, learning in supervised machine learning is faster because the correct output is already known. The model quickly adjusts its parameters using labeled data. Linear regression converges quickly due to known target values. Logistic regression learns faster compared to unsupervised clustering algorithms. This makes supervised machine learning is more efficient. So the next one you go with requires human efforts for labeling. Preparing labeled data sets requires human effort, time, and cost. Incorrect labeling affects performance. In the case of medical images, must be labeled by doctors before training diagnostic models. Images must be manually tagged for training object detection systems. So one limitation of supervised machine learning is the need for human effort in labeling data. Preparing labeled data sets requires time, expertise, and cost. Medical images must be labeled by doctors before training diagnostic models. Images must be manually tagged for object detection systems. Incorrect labeling leads to poor performance. So next one you go with easy model evaluation. Performance can be easily evaluated using standard metrics. This helps in selecting the best model. Example, accuracy and precision values are calculated for exam result prediction models. Confusion matrix is used to evaluate spam detection systems. Supervised learning models are easy to evaluate using standard performance metrics. This helps in selecting the best model. Accuracy and precision are calculated for exam result prediction models. Confusion matrix is used to evaluate spam detection systems. Clear evaluation makes supervised learning reliable. The next one is better interpretability. Many supervised models are easy to interpret and explain. This is useful for academic and industrial use. Decision trees clearly shows how decisions are made step by step. Linear regression explains how each feature affects the output. Many supervised learning models offer better interpretability. This decision-making process can be easily understood and explained. Decision trees show step-by-step decisions. Linear regression explains how each feature affects output. This is useful in academics and industries. So the next one you go with depends on data quality. The quality of labeled data directly affects model performance. Poor data leads to poor prediction. So therefore, the quality of the data determines the quality of prediction. Incorrect email labels can result in wrong disease prediction. Noisy training data reduces accuracy in fraud detection system. Therefore, the quality of input decides the quality of output. The performance of supervised learning depends heavily on data quality. Poor quality data leads to poor prediction. Incorrect medical labels cause wrong disease prediction. Noisy training data reduces accuracy in fraud detection systems. So, clean and correct data is very much essential for quality output. The next one is Risk of overfitting. Supervised model may overfit if they learn noise instead of patterns. This reduces generalization ability. A deep decision tree may perfectly fit training data but fail on new data. Memorizing training answers instead of learning patterns causes poor test performance. In fact, what exactly the overfitting? Overfitting speaks about the model perform well on trained data and poor on test data. This case we call it as overfitting. Then opposite, what is underfitting? The model perform poor on trained data as well as test data. In the model, we should never expect, even the model should not be overfitting and should not be underfitting. The last one is goal-oriented learning. Supervised learning always works towards a specific a target or goal. The learning object is clearly defined. Predicting whether a loan will be approved or rejected. Predicting whether a customer will buy a product or not. Supervised learning is always goal-oriented. The learning objective is clearly defined. For example, predicting loan approval or rejection, predicting whether a customer will buy a product or not. This clear goal makes supervised learning focused and effective.